In this tutorial, we'll be talking about Module 12 Electrochemistry Batteries, more specifically aluminum air batteries. Introduction and Review. The topics that will be covered in this tutorial are: what is a battery, how aluminum air batteries work from a chemistry perspective, what are the disadvantages and advantages of the aluminum air battery, what is the sustainability of the aluminum air battery, what potential technology can the aluminum air battery provide. Let's do a quick review of the basics of electrochemistry. Electrochemistry is the study of chemical processes that causes electrons to move. The movement of electrons from one substance to another occurs in a reduction-oxidation reaction, also known as a redox reaction. When a substance loses an electron, that means it's been oxidized. We can also say that the substance's oxidation state has increased. When a substance gains an electron, that means it's been reduced, or its oxidation state has been decreased. Now that we've finished the review, let's get into talking about batteries. A battery is a system that converts chemical energy into electrical energy through a redox reaction. In this system, electrons are transferred from one material to another through an electrical circuit. The traditional system of a battery is set up so that there are two metal electrodes, one electrode being the anode, where oxidation occurs, and one electrode, known as the cathode, where reduction occurs. Depending on the system, the anode or the cathode would either be positively or negatively charged. For a galvanic cell, the cathode is positively charged and the anode is negatively charged. For an electrolytic cell, the cathode is negatively charged and the anode is positively charged. An aluminum air battery functions by the oxidation of aluminum at the anode and the reduction of oxygen at the cathode. This is the oxidation half reaction, the reduction half reaction, and the overall redox reaction. In-depth discussion of concepts. How does an aluminum air battery work? From the air, oxygen enters into the battery. A catalyst assists to prevent carbon dioxide from entering. Oxygen reacts with water. The potassium hydroxide electrolyte solution removes the electrons from the reaction and forms hydroxide ions. Hydroxide ions react with aluminum to form aluminum hydroxide. The electrons are released and move from the aluminum cathode to the air anode through the external circuit. The electrons move through the circuit from the cathode to the anode to make up for the lack of electrons in potassium hydroxide electrolyte solution caused by the cathode reduction reaction. Advantages of the aluminum air battery. The battery uses oxygen within the air as a cathode, which eliminates unnecessary weight and as a result making it lightweight and compact. Aluminum air batteries have a very high energy density. Energy density is the amount of energy that can be stored in a given mass of a system. Aluminum is able to store and deliver high amounts of energy per pound than most known materials. Aluminum is one of the most abundant materials in the Earth's crust and an inexpensive material to mine. Disadvantages. Aluminum air batteries are non-rechargeable, which are also known as primary cells. Once the battery is out of power, the aluminum electrode must be replaced. Therefore, if this technology was to be made commercially available, then a station for battery replacements must be readily available. This would be equivalent to gas stations we have now. It is true that aluminum is an inexpensive material to mine. However, a refinement process must occur, which can be expensive and tedious. Aluminum does not come in a pure state, instead found as bauxite, a mixture of hydrated aluminum oxide, also known as alumina, silicon dioxide, known as silica, and iron oxide. From bauxite, alumina is extracted through what is known as the Bayer process. Then from alumina, the Hall-Héroult process is used to produce aluminum. This process is also known as aluminum smelting, which uses electrochemistry where aluminum ions are reduced at the cathode into aluminum metal, and carbon is oxidized at the anode into carbon dioxide gas. I won't get into the specific details of the process, but to the right I've provided a simplified diagram to give you a rough idea. With 4 to 5 tons of bauxite produces 2 tons of alumina, which then in turn produces 1 ton of pure aluminum. Corrosion can occur between the aluminum anode and the carbon dioxide within the air. However, Finergy, a company specializing in metal air technology, has developed a silver-based catalyst to impede the movement of carbon dioxide into the battery. After 1 month of storage, a rechargeable lithium-ion battery loses approximately 5% of its charge, whereas a non-rechargeable aluminum-air battery can lose up to 80% of its charge within the same time frame. Corrosion occurs in the aluminum-air battery between the aluminum anode and the electrolyte solution, as we can see in the pictures to the right. When the battery is not in use, the electrodes within the solution eats at the aluminum, causing corrosion. To combat this problem, the Massachusetts Institute of Technology designed an oil barrier between the aluminum anode and the electrolyte. When the battery is not in use, the oil barrier protects the aluminum from the electrolyte solution. When the battery is in use, the oil barrier pumps away and the electrolyte solution takes its place. This mechanism works because aluminum repels oil when submerged in water. Therefore, when the battery activates, the electrolyte solution is able to expel the oil barrier and restore the battery's function. With the oil barrier, the battery will only lose 0.02% of its charge per month. This is a huge improvement. Furthermore, with the design of the oil barrier, the battery used as a range extender can be stored for up to a month. Although MIT researchers have extended the shelf life of the battery, long-term storage for more than a month is still not an option. Restarting the battery after a long period of time without use causes it to degrade rapidly. These disadvantages are the reason why aluminum-air batteries are not being commercially produced currently. The impacts of aluminum-air batteries on the environment. Electrical vehicles reduce emissions while in use, as no carbon dioxide is being released into the air. However, the manufacturing of these vehicles produces pollution. This is due to the fact that electrical vehicles' batteries are made out of materials such as lithium and nickel, which needs to be mined to obtain. Likewise, with the aluminum-air battery, a mining process would still have to occur to obtain aluminum. As previously mentioned, a refinement process must occur to extract aluminum from bauxite. This process requires extensive amounts of electrical energy. Current electrical vehicles use lithium-ion batteries. These batteries are not being recycled, and most of them end up in the landfills or is incinerated. With the aluminum-air battery, the byproduct of the chemical reaction, aluminum hydroxide, is recyclable, which increases the sustainability of these types of batteries. Furthermore, aluminum metal is one of the few materials which can be 100% recycled. If aluminum-air batteries are to be commercially produced, the aluminum electrode, which needs to be replaced after running out of battery, can be recycled. With that being said, the production of aluminum-air batteries, which involves a refinement process that uses large amounts of electrical energy, has a negative impact on the environment. Furthermore, the fact that aluminum electrodes within the battery must be replaced each time after running out of power makes these types of batteries have a negative impact on the environment. Although the aluminum electrode can be recycled, the recycling process of aluminum still needs electrical energy to occur. If we take into consideration the refinement process and the recycling process of aluminum, immense amounts of electrical energy is required to carry out these operations. In conclusion, the production of aluminum-air batteries does have a negative impact on the environment. However, if aluminum-air batteries do replace lithium-ion batteries in the future, it would be a huge improvement in terms of sustainability of batteries of electrical vehicles. Real-world applications. Potential technology. Currently, aluminum-air batteries have been utilized as extenders for electrical vehicles. When the car's lithium-ion battery runs out and a recharge is unavailable, aluminum-air batteries have been useful as a substitute, allowing the vehicle to run even further distances. In the future, experts believe that aluminum-air batteries have the potential to replace lithium-ion batteries and gasoline. If technology is able to advance and more research is conducted on this type of battery, most land vehicles such as cars, buses, trains can also be powered by batteries. Due to aluminum's high energy density, I believe one day we'll see an airplane which is also powered by aluminum-air batteries. However, there are many problems that need a solution in regards to these type of batteries. The future goal I would like to see is aluminum-air batteries which are able to recharge, that can be recycled, and enable users to travel longer distances. To the right is a picture of Finergy's aluminum-air powered vehicle.